In this video, I'm going to talk through an exercise in creating drone mapping flight plans for a theoretical scenario in which you have been asked to collect drone data for an environmental monitoring program for a nature reserve in California. A written version of this exercise can be found at this URL, which will also be in the description. In this scenario, the director of the Hastings Natural History Reservation, which is a real reserve under the University of California Natural Reserve System, has hired you to fly a drone for a long-term environmental monitoring program. Hastings is a wonderful reserve in the Carmel Valley in Central California and is predominantly oak woodland. The goals of the long-term monitoring program and your drone flight includes detecting and measuring tree mortality, modeling habitat connectivity, planning fire control strategies, tracking feral pig damage, and monitoring illegal activities, such as unauthorized camping, pot growing, and dumping. So here are some of the details. You have been given a study area, which is shown here in red, and is approximately 400 acres in size. So that should tell you right off the bat, this is going to be too large of an area to do in a single flight. So depending on what equipment you have, you're probably going to have to do multiple flights. There are some roads on the western and southern edges of the study area. It is oak woodland. You can tell from the contour map, as we see here, that this is a hilly area. So you're going to have to take into account elevation. Another tidbit is that there's lots of poison oak. So I don't know about you, but I don't want to be trudging through the forest and getting poison oak while carrying drones. So we're going to try to stay on trails as much as possible. The analysis for the project will probably include some kind of classification of this area into broad vegetation classes, such as oak woodlands, maybe some conifers, maybe some shrubs, maybe some grasses and bare ground, fairly broad categories. There's an expectation that we will want to look for feral pig damage, maybe through classification, maybe through visual inspection of time images over time, and probably computing a canopy height model. So basically an elevation of the trees. The equipment that you have to work with is a DJI Mavic 2 Pro. This is a prosumer drone, which works very well for this kind of project. It has a good RGB sensor, which is 20 megapixels, a 1-inch CMOS, which is a global shutter. The flight time you can get from this kind of small drone is about 30 minutes, which if you're flying at 400 feet, which is the maximum legal limit for flying, you can get about 50 acres per flight on a mapping mission with a lot of overlap. It is a small drone, so you can't really see it very well beyond 800 feet. So our goal will be to launch it and fly it and not have it travel much beyond 800 feet. So how do we start planning this project? So here are some considerations that I would start with. First of all, what altitude are we looking at here? So given the goals of the project, I'm thinking 400 feet, which is the maximum legal limit, will be fine for this project. It is a large area. Flying higher means you can cover larger areas. And I know from experience that with this drone, if I fly at 400 feet, I'm going to get a pixel size or a ground sampling distance of a few centimeters, and that's going to be fine. We're trying to classify trees and shrubs and dirt and rocks. We don't need centimeter pixels. A few centimeters will be just fine. Do we want to have single or double grids? So in this example, I think a single grid is going to be fine. From experience, I know that oak woodlands have lots of texture. There's lots of shadows and there's lots of texture in the images. This is not difficult material for the photogrammetry software to stitch. So single grids will be fine. We don't need lots of look angles. This is not wispy grasslands or eucalyptus trees with those little leafy leaves. Oak woodland and chaparral, they tend to stitch really well. How many flights? That's a good question. Ballpark figure, we know this is 400 acres, the study area, and we know the maximum we can get under good conditions with the Mavic 2 Pro is roughly 50 acres. So more or less, probably a minimum, this will be 8 flights, maybe up to 10 or 12. But ballpark, let's say 8 to 12 flights is what we're going to need. So that will help me kind of get my head around how long it's going to take. This would probably be a 2-day project. You can't easily do more than, say, 4 or 5 flights in one day. Think about each flight might take 30 minutes to fly, maybe 15 minutes between flights to swap out the batteries, update your mission plan. And you don't want to be flying in the early morning and the late afternoon. So 4 hours of flight time per day is pretty reasonable. So I'm going to plan maybe 2 days, maybe four or 5 flights per day. The next thing I'm going to look at is in this study area, in this red boundary, where are the peaks? Where are the ridges? I don't want to run into a hill. I don't want to run into a tree. So I'm going to look at these contour lines and kind of figure out how high the hills are. And depending where I'm going to launch from, that can tell me how high I need to fly above the launch point. I'll then look at maybe some potential launch points. What we see here in this map is contour lines. And with a semi-transparency, you can see a satellite image. And I can see broadly from the satellite image where the clearings are. And then this black line is a road. There's another road along the southern border of this flight line. So I know that roads are easy to get to. I see some open areas in the tree cover. So these are my potential flight areas. And I'm going to go to CalTopo in a second to look at these in a little more detail. But in broad terms, it looks like there's some flight areas over in this part of the study area. There's definitely some flight areas at the top of the hill right up here. I can see that there's probably 4 hills I need to be aware of. There's something here called School Hill. There's another hill very close to that. There's a big hill, it looks like up in the corner, up in the northeast corner of the study area. And it looks like there's another hill down in the southeast corner. So I'm going to zoom in and look at the actual elevation of those hills to see where I can launch from to make sure that I'm high enough to clear those hills. Or ideally, I could even get up to the hills and launch from there. The other thing I can see in the satellite image, it looks like there's a trail of some sort that goes up to the peak of these hills. So these little white spots, I can see, where I might be able to actually walk with my drone, assuming I can park along this road here and get up to a clear spot, hopefully a flat, clear spot to fly the drone. So that gives me some general ideas to start with. When I won't try to fine-tune the flight plans at this point, such as in general, you want the drone mission to start far away from you and work its way back to you so that when the mission is over, it's close to the landing point. In case there's an issue and you need to bring it home early, it doesn't have too far to go. I'm not going to worry right now about the angle of the flight lines, which might be determined by wind or sun angle. But this is kind of the beginning of planning the set of flights that we need to cover this study area. So at this point, let me click on this URL, which will be in the description, and this will take me to a CalTopo web map. And here it is. So CalTopo, if you're not familiar with it, it's a website that is a little bit similar to Google Maps, but it has a lot more options. And it's one of my favorite websites for planning drone field work because it allows you to upload KML files for your flight area. You can see here, in addition to the study area, I have a KML for the boundary of the reserve, which is important because if I'm going to be flying outside of the reserve, I need to think about who are the landowners on the other side of the boundary. I like that. And this website in particular has a very impressive number of optional layers that you can display in your map that are publicly available. So what I've displayed here, as you can see, if I zoom in, includes contour lines, which is really important in drone mapping, and that is semi-transparent with a satellite image. So in general, these are my two favorite images to display for fieldwork planning. So very broadly here, I won't go into a great deal of depth, but in general terms, I know that this red boundary is about 400 acres. I know that I can fly roughly 50 acres, so I'm going to have to chop this up into between 8 and 12 flight areas. I also know that I want to find launch points that ideally won't be more than 800 feet, maybe up to 1,000 feet away, the maximum distance, so that I can keep an eye on my drone for safety. So there's a little ruler tool or distance tool, and one of the options there is distance. So let me just start with this corner up here, and if I click on this corner, and then you can see up at the top up here, you can see the distance of the line that I'm drawing. So this corner of the study area, right about there, is about 800 feet. So to get up to that corner, ideally, I'm going to be launching somewhere up in this little triangle up here. So I don't know this area. I'll make a final determination, but I'm kind of thinking that maybe if I zoom in, I see there's a pretty nice trail up there. I don't know if it's a fire road or just a nice trail, but I can probably hike up this trail. Fingers crossed, I'll find a flat space to launch from. So this is going to be one of my launch points, I think, somewhere up here. I don't know exactly where, but that's close enough. And if I launch from there, I can probably get 2 flights in, right? I can get one from up, maybe this area could be one flight, and then maybe another area below that. So that's a starting point, right? I'm going to start looking at that. So depending other access points, I could probably get maybe 3, possibly 4 flights on the eastern edge of the study area. Likewise, I can move, I can see, if I zoom into the elevation to the contours, right? This is important. So if you zoom into the contours, I can see the peak, these contour intervals look to be, this is 2,000 feet, this is 2,200 feet. So that's 2050, 2100. It looks like these contour intervals are maybe 50 feet. 2050, 2100, 2150. Maybe a little bit less than that. So, but basically, I know that I need to clear all of the trees, and so I can assume that up here that might be 2250. So if I can launch from up here and I go up 400 feet, I'll be in good shape. I will easily clear all of the elevation up here. I can maybe even drop it down a little bit. If I have to launch from down below, suppose here's an example where if I wanted to launch from this spot, I would use these contour intervals to figure out how high are the hills around this spot. And this is the kind of thing I'll do in my flight software. So basically, I'll go back and forth between this kind of contour map and my flight planning software, which is Pix4D Capture, and make sure that I'm flying high enough to easily clear these hills. But I know if I launch 400 feet above the launch point, I can probably cover, let's say if I launch from here, this is going to be 50, 100, 150, 200, 250. So if I launch from here, I can cover a fairly sizable area. But this is the kind of detail you have to look at when planning flights, essentially. So next, let's turn to one of the apps you can use for planning drone flights. And today we'll look at Pix4D Capture. Pix4D Capture is just one of many apps that you can use to plan drone flights for this kind of project. Pix4D is a free app. You do need to have a Pix4D account, but the free accounts work fine. If you do want to stitch your imagery using Pix4D Cloud, their cloud processing services, that's integrated nicely into their app, that does require a paid account. But we won't use that. We're going to plan to just basically use this app to fly the flight, to collect the images, and then we will get the images off the memory card and then stitch them on our own. So that's how we're going to use this app. And the majority of the flight planning apps, the mission planning apps out there are free, and you can use the manufacturers or the company's stitching services, or you can just use the apps and stitch the images yourself. So Pix4D specifically, it's important to kind of know that the way these projects are organized. So the main unit of organization is a project, and within a project, you're going to have multiple flights or missions. So the word mission and the word flight are synonymous in the Pix4D world. This app is available for both Android and iPads. There is one big limitation, however, with the iPad version of Pix4D Capture, and that is that you cannot import a KML, which is really helpful, as we shall see. When you first open Pix4D, if you're opening it for the first time, you will need to log in with a valid Pix4D account. Again, the free accounts are fine. It's then going to take you to this setting page, which is the settings for the app as a whole. And here you can select your drone that you're planning flights for, as well as a number of other options for the app as a whole. Next, when you're ready to actually start planning flights, you might see this screen, Plan a New Mission, also meaning plan a new flight. And it looks like here we don't actually have an active project. So you can click one of these flight plans and it will create a project for you. This is what the project screen looks like. So when you see a screen like this, you're kind of in project mode. So if there are flights that have been created for this project or missions, you will see them listed here. The project screen is where you're going to import your KML. If you click the little dots there, you'll have an option to import a KML of your study area, which presumably you've already downloaded to your mobile device using email or Google Drive or something like that. All of the missions that you have created for your project appear as tabs here, so you can click one and then open it, delete it. If you need to add a new mission, you can click the little plus button. You can open the current mission here and go back into the kind of flight planning editor, and you can add a new mission there. So this is what the flight or the mission planner editor looks like. You'll see something that looks like this depending on what type of flight you're flying. Let's talk through some of the buttons, and then we'll go to a live demo in a little bit. So the little button down here in the corner will basically pan your view to wherever you are currently located, or wherever the tablet you're using thinks it's located. Okay. If you click this little other button over here on the right side, this will create a new flight area. It'll basically, any flight area that exists, it'll move it to the middle of your current view. So wherever you've zoomed in, I will often have to, pinch and zoom out and then go to where you need to be. And then the next thing I would do would be click this little button here, and it'll create a new flight plan in the middle of your in your view, whatever the view is. You can use your finger and click on one of these flight lines and rotate it, and that will change the direction of the flight lines. Usually I do that probably towards the end of planning a flight, but that's always available. Over here you have a little scroller. You can slide your finger up and down to select the elevation or the altitude above the launch point. Okay, and that's easy to do. When you change the altitude or you change the size of your area, this little box down here will automatically update. It'll tell you the size or the dimensions of your flight area and how long it expects to take to fly it. So that's quite useful. You get automatic feedback on how long it's going to take. So that's a key thing to look at as you're designing your flights. If you're flying a polygon mission, which is what we have shown here, if you need to add another node to your polygon area, you click the little plus signs in between the corner nodes. And if you want to delete a node, you can take one of these nodes and just drag it on top of another one, and that is how you delete nodes. So between the plus signs and moving and deleting nodes, you can adjust the polygon to whatever shape you need it to be. Okay. And if you have a flight plan already, but somehow your Pix4D capture view is somewhere else, then clicking this little button will pan you to the current flight area for this mission. This is an important button to remember. Before you turn off your tablet or do anything else, click that save button, because the save button, it will save your flight to the project, but it will also cache any background imagery. So right now we're not showing the background imagery. If I click this little button down here, it would show a satellite image. And when you're in the field, it really helps to see that satellite image. That gives you a visual reference that this flight is actually where you think it's supposed to be. So click that, and that basically caching means that the image is saved on your mobile device, on your tablet, and even if you're in the field and you don't have an internet connection, you will still be able to see that background image, and you will still be able to get a live update where you are and where the drone is. If you click on the little cog wheel, the settings button, you can see some of the properties for the flight. This is a bit of a close-up of that. And basically what you can adjust will be the angle of the camera. For drone mapping missions, usually we do nadir, meaning 90 degrees down. Sometimes you might do a little bit off nadir, maybe 75 degrees if you're trying to look under trees. This is also where you set your front overlap and your side overlap percentages. Changing the front overlap will not add or delete flight lines, but if you change your side overlap, it's definitely going to add or delete more flight lines to achieve that amount of overlap. So think about that. You can also change the drone speed. Generally, if I'm flying high, I just let it go on the fastest speed. That gives me the largest coverage area. If I'm flying lower, or if I'm using a camera that has a rolling shutter, I might want to use a slightly slower speed to prevent blurriness. So it's a bit of work to plan your flights, but when you're done and you're out in the field, when you're all ready to go, you just click that start button. This assumes that you've already connected the drone to your mobile device using the DJI Control app. That's another tutorial. But basically, when you click that start button, it will upload the mission to the drone. It will do a series of checks. And when it's all done, you just click that start button. It starts beeping and then the drone lifts off. It's quite magical, and then you keep an eye on it. So it's really easy to fly once you've gone through all this work to put together your missions. So next, let's go into Pix4D Capture. I'm here on my Android tablet, and I've already installed the Pix4D Capture app from the Play Store. So I open it up. I've already logged into it with my Pix4D account, so I don't have to do that. This is usually where you will start. The first thing I would like to do is click on the settings wheel and make sure that the settings for the app as a whole are what I want them to be. So first thing I will do is click on the drone and select the Mavic 2 Pro, because I want the flights that I am planning to be specific for the Mavic 2 Pro. Another important setting that you would want to set for your Pix4D Capture as a whole is the Save Offline Maps setting. You probably want to turn that on. What that means is when you save a flight or a mission, the background imagery will also be saved on your device. So when you're in the field, even if you don't have an internet connection, you will still see that satellite image, and you'll see a little dot that indicates where you are. And between when you see that dot and you see the satellite image and you recognize the satellite image is where you're actually standing, then you're in good shape. So those are the two main settings for the app as a whole. The next thing I'll do is click one of our flight plans or mission plans. I'm just going to pick the standard grid mission. So what it has done here is it has created a new flight, but it's also created a new project. So if I zoom out a little bit, I'm not really sure where this default flight is located, but probably the first thing I would want to do, because I do have a KML file that I've downloaded to my tablet, which is the study area. So if I click on the settings wheel, sorry, that's in the wrong place. I'm going to click save here. And when I click save, I've basically saved that flight and I've saved that project. Now I'm in the project screen. And if I go to the three dots up in the corner, let me first rename the project. And I'll call this Hastings 2. And then if I click those three dots, you can see there is a load KML option there. So I've already loaded the KML for the area of interest onto this tablet using my email program. So it's called Hastings Proj KML. I can select that. So now that KML file is in my project. If I zoom out, I may or may not see it. Oh, there it is. Okay. So right now, this project has a single mission part of it, and I've selected that mission, and now I'm going to click open, and now I'm in the mission editor or the flight editor. If I pinch out, I can see where the default flight is located relative to my study area. And in fact, I'm going to go ahead and click the satellite image button. That will also help me. So I want to create a flight area for the upper northeast corner of the study area. I get it approximately in the right position. So before moving on, there's two things I should check. One is the altitude of the flight, and the second one is the overlap because these two parameters will determine how many flight lines there are. So I'm going to use my finger and scroll down the altitude slider here. And 400 feet is the maximum legal limit above the launch point. I usually go a little bit less than that. I have discovered that if your Pix4D capture mission plan has a flight altitude that is greater than the flight altitude limit that you've set in DJI Go, then you get a cryptic error message. So just to be safe, I set it a couple feet less than that. Maybe I'll set it like 390 feet. Okay. So that's 390 feet. I can see down here in that little box in the lower left, it's telling me that this current flight area will take 18 minutes to fly. All right, so I take note of that. However, before I go any further, I'm going to click on the settings wheel and double check the flight settings, which include the speed. I often leave the speed on fast. That works well if you're flying high, such as 400 feet. I know that the Mavic 2 Pro has a good RGB camera with a global shutter, so I'm not really worried about blurriness. So leaving it on fast is fine, and it also, lets me cover a slightly larger area. The angle of the camera, I'm going to leave it at pointing face down or nadir. That's a 90-degree angle face down. For this kind of project, I don't need to make it slightly off nadir because I'm flying pretty high. So that's fine. The amount of overlap, the default setting here is 80%. That's 80% side and forward overlap. I'm going to leave that at that level. Could drop it down to 70, but 80 is a little bit more safe in my experience. I would hate to get back to the office and stitch these images and find out that maybe it was a little bit windy or there's a little bit of, I don't know, haze or something, and they're just not stitching well. So a little more overlap is gives you a little bit of buffer. I rarely would go above 90%, so I'm usually between 80 and 90%. Above 90%, your flight lines are really close together. You can't cover a very large area. And to be honest, you just don't get that much better stitching capability. In fact, in some ways, you can be worse because when you have images too close together, you're giving the software data that's not really adding more value. Okay, and then the face setting for the flight, that doesn't apply for this kind of mission. That applies when you're maybe doing a circular mission, for example, around a statue. So I will click the wheel icon again to close up the settings. I'm happy with those settings. And I'm more or less happy with my flight. It's pretty close. One thing I should do is move the edges of the flight area a little bit beyond my study area. Rule of thumb is you want to go one flight line beyond your study area. Again, that's so you can have enough images at the edge of your study area to have to have good stitching, to have enough images on every feature on the ground to be able to triangulate where that feature is located in three-dimensional space. So extend your flight area beyond your study area by about maybe 10% or one flight line. The other thing I'm observing here in the little box down there, it's telling me that the dimensions of this flight area are 1622 by 1570 something. Oh, there we go. So I clicked it and it popped up. And I know that I can see my drone for about 800 feet. I'm pretty comfortable with that, which means that if I'm in the center of this area, and if I launch from the center of the area or close to it, then even at the farthest corners, the drone will be 800 or 900 feet away at maximum. So that's not a bad distance. That assumes that I can launch from the center of this flight area. But looking at the map and that little nice path that goes up there, I'm gonna use this for my assumption for right now. So, and it's 18 minutes. That's pretty good. The Mavic 2 Pro in theory could fly 30, 34 minutes. Of course, I don't want to land it when the battery's 0. I want to land it when the battery's maybe 20%. So that means really flight time is more like 20 minutes. And it's going to take a bit of time to get to altitude. It's going to take a bit of time to get to the first waypoint. So 18 minutes is pretty good. I'm going to leave it at that. If I needed to adjust the angles of the flight lines, I can use my fingers and rotate this whole thing. I'll do that when I get to the field, though, because that's going to depend on which way the wind's blowing. I definitely do want the final endpoint to be close to where I land. That's preferable, so that or at least it's going to be upwind, so that when the drone is done, it's not fighting the wind to get back to the landing pad. But I'll make that final determination when I get into the field. But for right now, this is good enough. If I zoom out, it looks like it's going to take me 2 more flights to cover the eastern side of the study area. That's fine. I'm going to click the save button. So now this first mission is saved. And when I click the save button, also the background imagery is cached. So that satellite image is cached. If I want to create the next flight, then what I can do is I've got the mission 1 selected. I can click the plus button again and pick another flight plan. I'll use the same flight plan. And basically what it does is it clones the mission that you had selected when you click that plus button. And I can just move it down. And that's pretty close to that'll cover my next flight. So this assumes that I can find a good flight area, again, somewhere in the middle of that flight area, a good launch area, somewhere in the middle of that flight area. Anyway, that's the general idea, right? So obviously, when you get to the field, you're going to have to fine tune all of this, but at least you can get a start. And even when you're in your field, you're basically going to be using the same app, the same device, and doing these same things. So that gives you a little bit of demonstration of how you can use Pix4D capture for this particular project goal.